Hey guys, I'm going to go through the 2.C basic exponent rules DeltaMath assignment and go through just a couple of examples of each one. I do have some paper over here, or virtual paper, to do some scratch work on, and you guys should have some probably as well. So let's start with exponent rules, variables only. And when you have exponential expressions, so something that has a base and an exponent, if you have the same base, then you can add their exponents, right? If you're multiplying them. So if you're multiplying two expressions that have the same base, so these both have a base of d, then you can add the exponents. Now, what secret exponent is on this one? Well, if there isn't an actual number written there, then I just have 1d times d to the 6th, which will give me d to the 7th power. So, because I'm just multiplying the bases, so I add your exponents. 1 plus 6 gives me 7. When you actually go to type this in, you can use the letter D, obviously, and then if you hold Shift 6, that'll pop it up into an exponent. You could also, if you needed to, click on this keyboard, and if you click on this button, that will make it pop up into an exponent as well. Okay. Go ahead and submit my answer. Hooray! They show you like technically what's happening, right? So method 1 is you could expand it all the way, which is just a lot of writing, or method 2 is adding the exponents. So that's how we got to our answer. Let's go ahead and do one more. So this one, when you have an exponential expression to another power, so we call this often a power to a power, what you do is you multiply the exponents. So if I have t to the 5th squared, that means I'm going to multiply my 5 and my 2, and then I'll end up with t to the 10th. So whenever you have an exponential expression with another exponent already on it, then you multiply those. So we get t to the 10th. Lovely. All right, so those are those types of problems. Let's go ahead and do some variables and coefficients. Okay. So this one I have negative 5k squared times negative 7k. So I'm going to worry about multiplying my coefficients first, right? So if I have negative 5k squared times negative 7k, I'm multiplying those. The first thing I'm going to do is whenever I have my numeric coefficients, I can multiply those together. So negative 5 times negative 7 would give me a positive 35. And then, since I have exponential expressions, so this is a k squared and another k, since they have the same base, they both have a k, then really I can think of them as k to the, and then I add their exponents. Remember, there's a secret exponent of 1 up there, so 2 plus 1. And so then my final answer would be 35k to the 3rd power. You don't need to write out all of this stuff sometimes. You can develop really good shortcuts in your head for doing it, but I just like to show my work. Multiply coefficients and add the exponents. Lovely. All right, let's look at this one. So in this example, I have 9q times negative 4q cubed. 9q times negative 4q cubed. So again, I'm going to go ahead and I'm going to multiply my coefficients first. So I have 9 times negative 4, which gives me negative 36. And then I'm going to, since my q's have the same base, and I can go ahead and add their exponents, right? I'll have q to the 1 plus 3, which will be q to the 4th. So negative 36, q to the 4th. Lovely. And the next one will be more of the same. So I'm going to go back and now look at negative exponents, and we'll look at the first type. So in this type of problem, it's going to be multiple choice. And so I'm going to kind of show you how we work through these ones. So basically we start off with this expression, right? X to the negative 3, and then x to the 4th, x to the 4th. Any time you have, or any time that we have a variable with a negative exponent on it, my way of remembering is is that it lives on the wrong side of the fraction currently. So an x to a negative third what would really happen is it would move to the denominator in the scenario since it started on top, and then you'd end up with an x to the fourth, an x to the fourth, and then an x to a positive third on the bottom, because that's where it now it's on the correct side of the fraction. One very big mistake I see a lot from students is when they remove everything from the top of a fraction, they think all of a sudden it's just gone and you don't have a fraction anymore. But remember, what number is always secretly multiplying each of these things? Well, that would be the number 1 was already up there. You could write a 1 in front of all of these, right? So just because I'm moving my x to the negative third down doesn't mean that there isn't anything up there anymore. There is still a 1, and these are still in the denominator, okay? So a lot of students would have accidentally picked x to the 11th in this scenario, but remember, your number 1 is still that placeholder that's up there. So then when we have exponential expressions that all have the same base, we go ahead and we add their exponents. So really you can look at this as 1 over x to the 4 plus 3. And so then that would be 11. So 1 over x to the 11th. Nice job. And you'll see they kind of set it up exactly the same way that I did. All right, so now let's do this one. So in this problem, please ignore any of the loud noises you hear out my window. So in this scenario, we got an x to the negative fourth, an x to the negative 6, a y squared, all over a y to the 6. And so I right off the bat, I'm going to look and say, hey, these things have negative exponents, so I'm going to go ahead and put them where they belong. They're currently on the wrong side of the fraction, so I'm going to put them where they belong. Y squared, it's good to go, right? I got y's up top, I got 2 of them, all right? So that's still up there. On the bottom now, I have a y to the 6, and then it doesn't actually matter what order you put them in. Even though I drew these arrows on each side, I can still just list the x's next to each other. It's all multiplication. All right, and so then now for the y's, because I have some on both sides of my fractions and they're where they're supposed to be, some of them will end up canceling each other out. And so the way I always phrase this question is, where do I have more y's? And you hopefully will tell me the bottom, because I have 6 of them down there. And then how many more do I have down there? I have 4. So if I went through and I canceled things, right, I would end up with, for this section, I don't want to use the same color. For this section, for my y's, I would end up with just 4 y's on the bottom, because that is where I have more of them, right, and how many more I had. So 2 on top canceled with 2 on bottom, and I was left with 4. Doesn't mean that on top everything's gone and disappeared, right? Because, because I still have the secret number 1 that's always multiplying everything on top, so that should still be up there. And then on the bottom, I had x to the 4th and x to the 6th, so really we can think about that as x to the 4 plus 6, because you're multiplying exponential expressions that have the same base, so you add their exponents. So x to the 4 plus 6 would be x to the 10th. So I have 1 over y to the 4th, x to the 10th. 1 over y to the 4th, x to the 10th. Lovely. All right, let's try one more. So for this one, I have x to the negative 2, y to the negative 4, over x to nothing, but secretly there's a 1 right there, right? And then y to the negative 6. All right, so I'm going to go through and I'm going to move my pieces that have negative exponents. So those 2 are both going to have to come down. And then this one is currently living on the bottom of the fraction with a negative exponent. It's going to have to come up. So let's see, if I bring down these guys first, so I'll have an x squared and then an x, and then a y to the 4th on the bottom now, and then the only thing that got moved to the top was my y to the 6th. Lovely. All right, now here with my y's, where do I have more y's on top? How many more do I have? 2, so I'd end up with just 2 y's on top. And then in my denominator, I have 2 x's here and 1 x here, right? So I am multiplying exponential expressions that have the same base, so I add their exponents, and that has a secret exponent of 1. So then I end up with x to the 2 plus 1. So overall, I'd get y squared over x cubed. So those are how those problems work. All right, last one is negative exponents type 2. So this one we are going to write the following expression without negative exponents and without parentheses. So this time you're producing your answer yourself. So I have negative 5x to the negative 1. All right, I notice that I have a negative exponent piece, and look, that negative 1 only applies to the x, right? It's not negative 5 to the negative 1 and x to the negative 1. It's just on that x, so that's the only one that will move to the bottom of the fraction, right? Secretly, these guys are over 1 to begin with. We just never write that part, and so when I move him to the bottom, my negative 5 stays up top, and then I just have 1x on the bottom. So you can write your answer, negative 5, and then I use the slash symbol for a fraction, and it's okay if your negative doesn't like go with your 5. If you really want it to be up there, you can, but you can also just leave it out front. So negative 5 over x, and I believe you can either leave it as x or you can do x to the first power, and either way you'd be correct. We'll see. Yep, so you can either leave it as negative 5 over x to the first or negative 5 over x. You would be fine either way. All right, let's do this one, writing this one without negative exponents and without parentheses, so 3x to the negative 2. My x to the negative 2 is living on the wrong side of the fraction, so it has to go to the bottom. So I end up with 3 over x squared. All right, let's do one more. So for this one, I have negative 3x to the negative 1. I notice that when I have my exponential expression with a negative exponent, so that guy has to move to the bottom. And I then have negative 3, still staying on top, over x to the positive 1. 3 over x, and I can just leave it as x, right? Because x to the first is the same as x. You also can leave your negative out front, or it can come up here with your 3. That's fine. And there we go. All right, let me know if you guys have any questions.